Exposure to noise pollution can cause a significant impact on an individual's physical and mental well-being. The European Environmental Agency stated that long-term exposure to noise is estimated to cause 12,000 premature deaths per year. Road traffic noise is the most dominant source of environmental noise. 20% of the European population live in areas where traffic noise can cause significant harm to health. Traffic noise pollution is more severe and widespread than ever before. This final year project aims to address this global issue by developing a 3D acoustic model that represents the traffic noise pollution affecting a residential area. This three-dimensional acoustic simulation is a computer program developed in Unreal Engine that enables the user to walk through a 3D model of an estate. Road traffic is programmed to drive along a motorway that runs adjacent to this estate. The user experiences traffic noise pollution in real time while being given the tools to reduce it. This study examines the techniques of propagating noise pollution, reflection and absorption techniques, the process of creating 3D models, and exploration of the 3D noise map. To what extent can an acoustic simulation represent traffic noise pollution in affected residential areas? This question is explored throughout each process of this final year project. Common Noise Assessment Methods, or CNOSS, is a report developed by the European Union for member states to develop strategic noise mapping. Chapter 3 of this report addresses road traffic noise. This section contains equations that evaluate the sound power level of propulsion, rolling, individual vehicle, and traffic flow noise. In this program, these equations presented in CNOSS are converted into code that evaluates a vehicle's noise per frequency band. The dB level per frequency band of an individual vehicle is applied to an equalizer. This equalizer scopes the sound of a white noise synthesizer into a representation of a vehicle's sound power level. The synthesizer is attached to a 3D model of a vehicle that travels through a virtual world. The user can input the average speed and vehicle category to experiment with different sound power levels. Users can input average speed, traffic volume, and vehicle category to simulate the long-term average noise of traffic flow along a source line. This project reflects, absorbs, and transmits the sound of traffic noise on the surfaces of buildings. This feature utilizes Steam Audio's ray tracing abilities to achieve realistic acoustics. Ray tracing is a digital reflection simulation technique that emits thousands of rays from a sound source's origin point. These rays travel in virtual space until they detect an obstructing object. As intersecting objects are detected, the original ray is clipped at the point of intersection. A transmission beam is then constructed, matching the shadow region. A reflection beam mirrors the transmission beam over the object plane. Steam Audio also binaurally renders direct sound using HRTFs to accurately model the direction of a sound source relative to the listener. Limerick City's Noise Action Plan stated that the council received a petition regarding excessive road noise from the M7 in the Monaleen area. This motorway was causing daytime and nighttime annoyance and sleep disturbance to residents in Monaleen Road, the Cherryfield and Thornfield housing estates. Due to this fact, a 3D model of the Monaleen area was developed using Mike Fricker's Street Map plugin for Unreal Engine 4. The 3D models of vehicles and houses were imported from the Unreal Engine marketplace. The house's exterior, ceilings, floors, walls, and stairs were all set to their appropriate material to ensure accurate reflection and absorption. The vehicles move along a road spline using a timeline in Unreal Engine blueprints. The user is encouraged to experiment with the average speed vehicles travel. Limerick City's Noise Action Plan illustrates that a 10% speed reduction can reduce noise pollution by up to 2.1 dBA. Users can also experiment with traffic volume. This number dictates how many vehicles are travelling along a spline at one time. Limerick City's Noise Action Plan states that a 50% reduction in traffic volume can reduce noise pollution by 3 dBA. The European Union Action Plan identified the need to implement measures to reduce noise at source. This measure includes the construction of noise barriers. This program enables users to simulate the noise pollution in monoline with and without a speed wall. To what extent can an acoustic simulation represent the noise pollution in affected residential areas? This project seeks to answer this question through its use of noise propagation equations, reflection techniques, and spatialization. This project then goes on to provide the tools that can allow users to experiment in the reduction of noise pollution.